My name is Kathy Mundy, and I am here to present to you the industrial pasta machine on behalf of the UF design team. Let me first off say, I'm sorry I can't be there in person, but I hope you find this video very informative. Now let's go ahead and get started. The first thing we need to talk about the pasta machine was we needed the feed rate to receive and emit the pasta at 5 meters per second. From there, we needed the width of the pasta as it was going into the rollers was 1 meter, and the final thickness of the pasta would be 1 millimeter. From there, we were able to work with a couple assumptions, and we first assumed that the radial load found in the rollers would be 100 newtons. And we also determined the coefficient of friction between the pasta and the rollers to be 0.2. And we also determined the conveyor transporting the pasta would need to be 1 meter off the ground. Now let me go ahead and show you a little bit of our design. Here's our design, and as you can tell, it is made of rollers, bearings, gears, and a motor. Those are the 4 basic things that enable this to work. Now let me go ahead and talk to you a little bit more in depth about each component. The first thing we needed to get going would be the motor. We determined this motor would be the best one suited for the project, for the pasta machine, because it emitted 1 horsepower and at 1725 rotations per minute. The second thing we needed were the gears. As you can tell, we have 2 separate gear trains. This one is for the rollers, whereas this one is for the motors. The tangential velocity was 5 meters per second, and we determined that the gear ratio for this one would be 1:1, whereas this one would be 2.77. Now, this gear train let's start with this one. This gear train allows the motor, it slows down the motor as the motor starts turning. So when this slows down, it then it turns the shaft, which then turns these gears, which enable everything to work at the specified speed. As you can tell, we already picked out what gears you would need to use. The other thing we needed would be the bearings. We went ahead and went with a cylindrical roller bearing because we determined it would be best suited for this particular machine. If you notice on the diagram that the bearings were located on the shaft and it was rotating, so we determined that this type of bearing will work best for the project, this specific bearing. Now let's talk a little bit about how long all these pieces are going to last. First, let's look at the roller bearing. We have this equation, we went ahead and plugged it all in the nose, and we determined that the roller bearing would last for 8.56 times 10 to the 12 hours. So running your machine 24 hours a day, that's going to last for a pretty long time. The next thing we needed to work on was the gears and what material and how long these would last. We went ahead and chose the type 304L stainless steel for the gears because we determined it would be best suited for the gear train. So using all those calculations, we determined that as long as the largest stress inside the gears is less than 376 megapascals, the gears will not fail and have infinite life. We thought this would be important considering the gears are the part that is what rotates the motor, which allows the rollers to rotate and stuff. We also determined using the Goodman criteria and the Lewis bending equation that 13 millimeters is an acceptable face width, also for the gears to have infinite life. The next thing was the rollers. We also chose for the rollers to use the 301 or the 304L stainless steel. Using the Hershey calculator, we were able to determine the maximum pressure, shear stress, and tensile stress, so we knew what not to exceed within. So as you can tell, using the modified Goodman criteria, we determined that 1.89 times 10 to the 6 cycles was how many cycles it could endure. Now let's go ahead and give you an idea of how this pasta machine is going to be incorporated into your office, into your machine. First, we have the conveyor belt, which then takes the pasta dough and transports it through the sorter into the rollers, and then allows it to come out at the specified final thickness and carries through. Again, here's the final design. I hope you were able to understand everything and see how everything works together. Thank you for your time, and I look forward to working with you in the future. Thank you.